All right, when it comes to dividing rational expressions, it's ultimately a matter of knowing that division of fractions is the multiplication of the reciprocal of the second fraction. So anytime in elementary school where I had like 1/2 and I was dividing it by 4/3, this problem was supposed to rewrite to be 1/2 times 3/4. And then you would multiply straight across as in previous multiplication problems. The key here is that division is the multiplication of the reciprocal. So what you do is take this original setup and just rewrite it to be 6x over 7 times 5x over 2. And then treat these problems as if they were a simple multiplication of rational expressions, which requires us to just multiply straight across and then reduce if possible. In this case, we just multiply straight across and we should get 30x squared over 7 times 2 is 14. And then we reduce. Now I could have reduced first. I could have seen that the 6 and the 2 would have reduced to be a 1 and a 3. But here, we'll do it after the fact. Either way works. So the top and bottom have a 2 in common. So 14 divided by 2 is 7. And 30 divided by 2 is 15. So 15x squared over 7 would be my reduced, simplified, fully simplified quotient of these two fractions. So even though it was division at the beginning, it turns right into multiplication after you multiply by the reciprocal. Now again, had I seen right away that I could have reduced, it might have made the process a little more clear. If you divide this by 2 and divide this by 2, you get a 3 there and a 1 here. And then when you multiply to get 3 times 5, it would have jumped straight over to the 15. And then 7 times the 1 would have given you the 7 over here. Either way, you get 15x squared over 7. All right, in the second example of division, the same concept holds true. Anytime you're dividing fractions, you just multiply by the reciprocal of this second fraction. So you rewrite, first fraction remains, you don't flip it, leave it alone, 9x squared times second fraction reciprocal. So multiplication of the reciprocal. So 2x over 3. Then I reduce. So don't reduce until you have multiplied by the reciprocal, until you've rewritten the problem. So then essentially products of rational functions are able to be treated as if it's one big fraction bar where I can reduce vertically. Here I have an x and an x squared that I can reduce down. This x will reduce with one of these ones in the denominator, and then I multiply straight across. So I have 1 times 2 is 2 in the numerator over 3x and 9x times the 3, which will get us 27x. And then I take a second look just at the result to see if there's any further dividing to do, any reducing to do, and there is none. I have 2 over 27x.